Welcome. So this video is on the square root property, the SRP, square root property. We did talk about the square root property in a previous video on the Pythagorean theorem. We use the square root property to find the length of each side of a triangle, a right triangle specifically. Although we did omit the negative solution because we were talking about a triangle. So here we will not do that. We'll not omit the negative solution. Anyways, this square root property is used to solve equations such as what we have here. If x squared equals 16, we're going to use it to solve that equation. So it asks, what numbers would satisfy this equation? Well, 4 would work, but also negative 4 would work. Those are the square roots of 16. Yeah, 4 squared is 16, so is negative 4 squared is 16. So we're going to get that by taking the square root of 16 and then placing both plus and minus in front of the answer. So here's a property. For any real number a, if x squared equals a, then x equals the square root of a, or x equals the negative square root of a. Another way we could write that in a more condensed form is x equals plus and minus. So it's a plus sign right over a minus sign, or a negative sign. Plus and minus the square root of a. So this is the square root property. Okay, here's our first problem. Solve x squared equals 32. Okay, so we're going to use the square root property. And what that does is it removes the square on the left-hand side. And on the right-hand side, we put a square root. But we have to put the plus and minus also. So on the left-hand side, you get rid of the square. And on the right-hand side, you put a square root. Don't forget the plus and minus. If you forget the plus and minus, then you're omitting the minus, which means you're only going to give half of the answer. And if you give half the answer, at most, you can only get half the credit. So you don't want to do that. Okay, now simplify the square root of 32. So square root of 32 is 16 times 2. Square root of 16 is 4, so it's plus and minus 4 square root 2. And then we're all done. Put those in braces, maybe box it. Not too bad. So again, whenever we have x squared equals a number, get rid of the square on the left-hand side, put a square root on the right-hand side, and then a plus and minus, and then simplify if possible. It's not always possible. If that was a 29, there is no square root of 29, we can't simplify it. And we always want to write it in simplest radical form, unless it says to round to a decimal place. Here it does not say that. So then you always leave an answer in simplest radical form. Here's our next one. We're still going to use the square root property. We do have a binomial squared on the left-hand side. So we're still going to use the property. As long as we have something squared on the left-hand side equaling a number, we could use the square root property. So when we use the square root property, we're going to get rid of the square on the left-hand side, then put a square root on the right-hand side, and then don't forget the plus and minus. So there's that note. Use the square root property. Don't forget the plus and minus on the right-hand side, and then we'll simplify. So there it is. We got rid of the square on the left-hand side, which means we don't have to write the parentheses. And then we put a square root on the right-hand side. And we didn't forget the plus and minus. Now the square root of 24, let's see, you could do the prime factorization. There's 3 2's and a 3, so there's a pair of 2's. A 2 comes out, 6 stays inside. Most calculators, or many calculators, will just do that for you. So that's 2 square root 6. And now we're trying to get x by itself. What are we going to do? Right, add 3 to both sides. Now, it's proper form to put the radical last. It's not wrong if you put the radical first, it's just not traditional. So the radical part is written at the end of the expression. So x equals 3, because it's a positive 3. And then in front of the 2 square root 6, you need to keep the plus and minus. So 3 plus and minus 2 square root 6. We can't do anything else with that. We can't add the 3 and 2 or subtract the 3 and 2 because the 2 is attached to the square root of 6. So we'll box it. So this means there's two answers. 3 plus 2 square root 6 and 3 minus 2 square root 6. Okay, our next problem, x squared equals negative 72. All right, cool. We got something squared on the left-hand side, so we're going to use the square root property. Get rid of the square on the left-hand side, put a square root on the right-hand side, and don't forget the plus and minus. Now we can simplify the square root of negative 72. It's got a negative inside, so that just means we need to get rid of the negative, but we put an I in front of the radical. Okay, so there we did that. We put the I in front, not in front of the plus and minus, just in front of the square root. Now simplify the square root of 72. Either use the prime factorization method or write it as a product of two square roots, where one is the largest possible perfect square root, which will be 36. So that gives us 6 square root 2. And then you can put the I right after the 6. So again, the plus and minus stays in front of that whole thing. If you wanted to, you could put the I after the square root 2. Just make sure it's far enough away so that the I is not underneath the radical. That's it, we're all done with that problem. We still got a couple more. Right, here's our next problem. 5x squared equals 8. We need to have something squared on the left-hand side. We don't. There's a 5. The 5 is not squared. Only the x is squared. So before we could use the square root property, we needed to divide by 5 on both sides. So if you divide by 5 on both sides, that gives us x squared equals 8/5. Now we could use the square root property. So a lot of people will use the square root property too soon. You need to get something squared by itself, whether it's a binomial squared or a variable squared. A square root property, get rid of the square on the left-hand side, put a square root on the right-hand side, and don't forget the plus and minus. Okay, now we have to simplify that. We have a radical 5 on the bottom. Right, do you remember rationalizing the denominator from the last chapter? Yeah, of course. So we're going to multiply top and bottom by square root 5. You could have also simplified the square root of 8 first, but we're doing it this way. So what do we get? If we multiply the top by square root 5, that gives us square root of 40. And on the bottom, we get the square root of 25. And then square root of 40 is 2 square root 10. Square root of 5, sorry, square root of 25 is 5. Don't forget the plus and minus. So there's our answer. Plus and minus 2 square root 10 all over 5. Okay, so on this one, we still have another binomial squared on the left-hand side. That means we could use the square root property. We have to have something squared on the left-hand side, LHS, left-hand side, RHS, right-hand side. Just kind of shorthand. There's so much writing, right? Okay, so we have a binomial square. That means we could use the square root property. Get rid of the square on the left-hand side. Put a square root on the right-hand side. Don't forget the plus and minus. Okay, now square root of negative 16. Let's see, the square root of 16 is 4. And then we have to take an I out to get the negative out of the radical. So it's I times 4, which is 4I. So x minus 3 equals plus and minus 4I. Almost done. We have to add 3 to both sides to get the x by itself. And again, when we write this in standard form, whenever you have an I, standard form is always a plus bi. So we want to put the 4i last. So that's 3 plus and minus 4i. Again, what does that mean? It means there's two answers. One of them is 3 plus 4i, and the other one is 3 minus 4i. Okay, here's our last problem. We have a binomial squared on the left-hand side, so we can use the square root property. Get rid of the square on the left-hand side, put a square root on the right-hand side, and don't forget the plus and minus. So 2x plus 1 equals plus and minus the square root of negative 45. Okay, a few things to do here, right? We have a negative in the radical. That means we're going to put an I in front. And then we're going to simplify the square root of 45. 45 is 3 times 3 times 5. So we're going to pull a 3 out and a 5 stays inside. Okay, so there we go. We have 2x plus 1 equals plus and minus 3i square root 5. Again, 45 is 3 times 3 times 5, so there's a pair of 3s, so a 3 will go in front of the radical, and a 5 will remain. Because there's a negative in the radical, we put an I in front, because I is equal to the square root of negative 1. Okay, now we got to get x by itself. So the next thing to do is subtract 1 on both sides. So now we're going to rewrite that. Remember, the radical is always last. The I is always last too, right? So it's negative 1 plus and minus 3 square root 5. I put the I at the end. It doesn't have to be, but in this case it will be because we're going to have to separate it. You'll see what I mean in the next step. Okay, what is our next step? We need to divide everything by 2, right? So don't forget, standard form is a plus bi, or a minus bi. Remember, it's got to be the real part, and then the imaginary part. So divide all of them by 2. So on the left-hand side, the 2's cancel, we just get x. And on the right-hand side, just keep it separate. -1/2 plus and minus 3 square root 5 over 2 I. And then sometimes we put that I right in the middle, kind of like y equals mx plus b. You know, if we had a slope of 2/3, we would write y equals 2/3 x plus 4, something like that. Okay, so hopefully everybody's okay. Again, we simplified the square root of 45, which is 3 square root 5. If there wasn't a fraction, I would probably just leave the I in front. But because we end up with a fraction, it's a good idea to put the I at the end to separate the real part from the imaginary part. Okay, I'll see you here for the next video. Bye.